Now let's first look at DDL. The most important DDL command is the CREATE command, which is used to create various database components such as schemas, tables, and views in a database. Create schema means defining the portion of a database that a particular user owns. Within the schema, users can create database tables with columns or fields using the CREATE TABLE command. And the views are logical tables that are not stored physically as a regular table in the database, but generated on demand in most cases. Views are often created to make data queries simpler for the users, as they provide a place where all the data points a user needs are stored. You have probably noticed that these SQL commands are quite intuitive and resemble natural language such as English. That is correct. Most SQL commands are very easy to understand, even by people with little information systems training. For example, the opposite for the CREATE command is the drop command. You can drop schema, drop table, and drop view to delete schemas, tables, and views. Of course, there are also some less intuitive commands that would require some technical background and more explanation, such as create character set, create collation, create translation, create assertion, create domain, and so on. But for the purpose of this course, we won't get into some of these more technical commands. Let's focus on the create table command here, because this would be a command that you use frequently. Before using the create table command, you need to first understand the SQL data types that can be used for various fields of a database table. This table lists some common SQL data types, including string or text data type, number data type, temporal, and Boolean data types. The most commonly used data type in a database are text and number data types. String data types include fixed length characters and variable length characters. For large string fields, you can use the blob or binary large object data type that can store up to 2 GB of data. The commonly used number data types are numeric, which stores exact numbers with defined precision and scale, and the integer data type. Another common data type that is not on this list is the date-time data type, which stores dates and time elements. Different database management systems may have different format requirements for the date-time data type and accept various functions to extract different parts of the date and time elements. For example, in Oracle, the function extract can be used to retrieve date elements such as year, month, day, and then in SQL Server, there are also the functions called year, month, or day that can do exactly the same thing. Then temporal data types such as timestamp are very useful in creating an audit trail for transactions. The Boolean data type is especially efficient as it only uses 1 bit, or a 1 or 0, to store information. As discussed in physical database design, assigning the right data types to fields would help improve the computational efficiency of a database. Now that we understand some of the common data types, we are ready to talk about the create table command. This is the general syntax for the create table command. You should follow the steps listed here to compose the create table command. First, you need to identify the appropriate data types for the attributes, and then determine which attribute cannot have no value. This allows the database management system to check the validity of the values inserted into these tables. You need to identify columns that must be unique and primary key foreign key mates. For example, fields like customer ID, product ID, or social security numbers should have unique values. This would allow DBMS to check for data integrity and the referential integrity in the future. You will then determine the default value and the domain constraints. So that only valid values would be inserted into these attributes. Finally, you will create indexes on certain attributes in order to improve the search speed when the table is queried. Now let's look at some examples of the create table command in the next few slides. This ER diagram describes a familiar business scenario where customers place orders, and orders contain order lines that include products. There are a total of 4 tables, including the order line table, which is an associative entity. The relationship between customer and order table is one-to-many, with customer ID being the primary key in the customer table and being the foreign key in the order table. Similarly, the primary key order ID in the order table is also a foreign key in the order line table, although it's not shown in this diagram. And the product ID, which is a primary key in the product table, should also be a foreign key in the order line table because of the one-to-many relationships. Now that we understand the structure of the tables, let's look at the create table commands for creating these 4 tables. These 4 create table commands, when executed, would create the tables and the relationships described in the previous slide. The tables are created using appropriate data types, domain, and the referential integrity constraints. Let's zero in on some of these statements to learn how the create table command works. Let's first focus on the commands for creating the product table here. The command starts with the keyword create table, followed by the table name product_t. It is important to remember that no 2 tables in the database should have exactly the same table name. Then, within a set of parentheses, you enter the attributes of the table. For example, in the product table, we have an attribute called the product ID, which is an integer field as it contains whole numbers, a product description field, which is a variable length character field, and we are going to reserve 50 characters for this field. And then the product finish field, which is also a variable length character field with a reserved length of 20 characters. The standard price attribute is a decimal field. that comes with precision and scale. The number is 6 digits long with 2 decimal places. Finally, the product line ID is an integer field. There should not be any space in the attribute names. It is customary to connect the words using an underscore for attribute names. Each attribute is then separated by a comma. Now let's look at how the constraints are defined in the CREATE TABLE command. This is the same command from the previous slide. Since each product must have a product ID, no value is not allowed for the product ID field. Therefore, we have the keywords not null after the data type for the product ID field to indicate that this field cannot have no value. At the same time, product ID is the primary key field of the product table because each product should have a unique product ID. Therefore, at the end of the command, we use the keyword constraint followed by a name for the constraint. In this case, we give the name product underscore pk, which stands for primary key, to this constraint. And this is followed by the keyword primary key to indicate this is a primary key constraint, and then end the statement with a set of parentheses that enclose the name of the primary key field, which is product ID. This statement tells the DBMS that product ID is the primary key for the product table. As a rule, the primary key should never have no value. Therefore, using the not null option for product ID attribute is somewhat redundant here because of the primary key definition. Now let's look at how composite primary keys are defined in the CREATE TABLE command. This command defines the structure of the order line table, which has the composite primary key of both order ID and product ID. As you can see, for composite primary keys, you simply include all the attributes within the parentheses in the primary key constraint statement. Now let's look at how we control the values in attributes when creating tables. These are the commands for creating the order and the product tables. For each order, there is an order date associated with the order. The data type for order date is naturally date. Okay. Also, it makes sense that the order date is the same date on which the order is created in the database table. Therefore, we use the keyword default followed by the default value for the attribute to define the default value. In this case, we use the built-in function sysdate, which would automatically put the current date in the field when a new order is created. In the product table, we want to make sure that the user follows the domain constraint when entering the product finish data. Therefore, we use the clause check followed by product finish in a list of allowable product finish values. This way, if the user mistakenly enters a product finish that's outside this list, the DBMS will return an error message. As product finish is a text field, it is important that you use single quotes around the product finishes and separate each value using a comma. Now let's look at how these commands define primary and foreign key pairs. This constraint is important as it defines the relationships between tables. In our example, customer table has a one-to-many relationship with the order table. So the primary key customer ID is a foreign key in the order table. To define the primary key, we use constraint followed by the constraint name. In this case, customer PK, and then followed by the keyword primary key to indicate this is a primary key constraint, and then the attribute name in a set of parentheses. Then for the foreign key, we must reference to its corresponding primary key in order to establish the relationship. So in the order table, we use constraint followed by the constraint name, in this case, order underscore FK, which stands for foreign key, and then the keyword foreign key to indicate this is a foreign key constraint. Then followed by the name of the field customer ID within a set of parentheses to indicate that customer ID is the foreign key in the order table. Then we use the keyword references followed by the names of the primary key field and the table. In this case, the customer ID field of the customer table, to show that this foreign key corresponds to the customer ID field of the customer table, which is the primary key. Do you still remember the concept of referential integrity? Now, this is an important concept to remember when creating database tables. It simply means that foreign key values of a table must match primary key values of a related table in a one-to-many relationship. In other words, if the value does not exist as a primary key value, then it should not be a foreign key value in a related table. For example, if you have an order placed by a customer with ID 123, but in your customer table, you do not have any customer with the customer ID 123. Well, that presents a problem to the business. Who placed the order, and where should the business ship the order to? As you can see from this example, ensuring referential integrity is important. In most cases, referential integrity is violated when records in database tables are updated. When a primary key record is deleted or updated, it sometimes can affect the foreign key table. For example, if a customer record is deleted from the customer table, then any order records in the order table that were placed by that customer are suddenly left without a corresponding customer record. That creates a data integrity problem. In addition, when a dependent record is inserted without a corresponding primary key record, it also creates a data integrity issue. So how do we deal with these referential integrity issues? Well, CREATE TABLE command also provides a solution for us. This slide shows a few slightly modified CREATE TABLE commands. The modifications are in bold letters. There are 4 ways to enforce referential integrity: restrict, cascade, set null, and set default. When you add the phrase onUpdate restrict at the end of the primary key constraint statement for the customer table, you are asking the database management system to restrict any update or deletion of the primary key value if a corresponding foreign key value exists in the related table. For example, if you choose to delete a record in the customer table, the database management system will first check to see if any related records exist in the foreign key table. If the related record exists, then the database management system is going to restrict you from deleting the record in the primary key table. If you choose the cascade option, any update to the primary key value will result in the same update in the foreign key value. For example, if the customer ID is updated from 123 to 234, then all the 123 customer IDs in the order table will be updated to 234 automatically by the DBMS. If Set Null option is selected, when the primary key value is updated or deleted, the corresponding foreign key value will be set to null value. Set Default works in the same way, except it sets the foreign key value to a predefined default value instead of the null value. Once the table structure has been defined using the CREATE TABLE command, you can still make changes to the structure as you see fit. Alter table is the command that you use for a wide range of modifications to the table structure. For example, to add a new attribute, you can use the alter table command followed by the keyword add, and then the new attribute names and the data types. To add a constraint such as primary key or foreign key, you will use the keyword add constraint. To change the data type of an attribute, you will use the keyword modify. And to rename an attribute, you can use the keyword rename. As you can see, alter table can be used in many different ways depending on the keyword that follows the command. To remove an existing table from the database, you can simply use the drop table command, followed by the table name as here. For example, drop table customer_t will remove the customer table from your database schema.